Out there, beyond the reach of our solar system, lies a galaxy unlike any other. It twists and bends like the ancient symbol of infinity, a cosmic riddle written in stars. But this galaxy hides a secret. In its luminous heart, something extraordinary is unfolding. Scientists believe we are witnessing the birth of a supermassive black hole for the very first time. Let that sink in. A black hole, not billions of years old, but newly born, a baby in cosmic terms. Captured by the James Webb Space Telescope and confirmed by a symphony of other observatories, this discovery could change everything we thought we knew about how black holes form. What created it? Why now? And what does it mean for our understanding of the early universe? Tonight, we journey into the heart of this celestial enigma. This is the Infinity Galaxy and the baby black hole it conceals. The galaxy scientists call infinity isn't just beautiful, it's violent. What you're looking at is the aftermath of a cosmic collision. Two galaxies, once separate, now twisting into each other in a slow-motion crash that's been unfolding for millions of years. At the heart of this collision, telescopes have detected a powerful glow, not from stars, but from something stranger. A compact region blasting out X-rays, radio waves, and light in ways that defy ordinary explanations. Astronomers believe this is where it all began, the birthplace of a supermassive black hole. But here's the twist. There was no exploding star, no dead supernova, no quiet fade into darkness. This black hole didn't die into existence. It was born through a process known as direct collapse. Imagine a giant cloud of gas, millions of times the mass of our sun, collapsing directly under its own gravity, skipping the star phase entirely. This may be how the biggest black holes in the universe come into being. It's a process we've only theorized, until now. Thanks to the combined power of the James Webb Space Telescope, Chandra X-ray Observatory, and others, we're finally catching the act as it happens. And what we've found might just rewrite everything we know about the early universe. But how do you spot something as elusive as a baby black hole, invisible, silent, devouring everything around it? The answer: you don't see the black hole, you see what it does. The first clues came from NASA's James Webb Space Telescope. It picked up an unusual infrared glow, deep red, far beyond what normal stars produce. The shape of the light matched something dense, compact, and incredibly energetic. Then, the Chandra X-ray Observatory zoomed in, and there it was, a point source of powerful X-rays hidden between two galactic cores. This wasn't random. It was radiation from gas being violently pulled inward, a signature of a growing black hole. Meanwhile, the Very Large Array, a radio telescope network in New Mexico, picked up faint but consistent radio signals from the same region, confirming something massive and magnetic was spinning at high speeds. Put together, it's like hearing the cries of a newborn, not with sound, but through light, radiation, and distortion in space. Each observatory gave us a different piece of the puzzle, and together, they painted a portrait of something we'd never seen before, a supermassive black hole at the moment of its birth. It took the entire toolkit of modern astronomy to reveal the universe's most secretive event. Until now, we believed that supermassive black holes, the giants anchoring the centers of galaxies, took billions of years to form. They were thought to grow slowly, feeding on stars and gas, merging with other black holes, step by step. But this discovery flips that idea on its head. If a black hole can form this quickly, not over billions, but just tens of millions of years, then something's missing from our model of the early universe. This newborn black hole supports the theory of heavy seeds. Instead of growing from small stellar black holes, some supermassive ones may have formed directly, from massive gas clouds collapsing under gravity. That would explain how black holes already existed when the universe was less than 1 billion years old. It also means the cosmic timeline we've trusted may need rewriting. Galaxies may have been shaped earlier, stars may have formed faster, and black holes, once thought to be the end of a star's life, may, in some cases, be the beginning. This discovery isn't just a photo of deep space, it's a window into time, a glimpse at how the universe builds itself, from chaos to structure. And perhaps, it's telling us we've only just begun to understand how the universe really works. In the stillness of space, where time stretches beyond comprehension, something profound is unfolding. When we gaze up at the night sky, we're not just looking at stars, we're looking at history, frozen light from billions of years ago. We're reading the echoes of creation, but every so often, something happens that breaks through that timeless silence, a whisper of the present among all the ancient light. The discovery of a newborn supermassive black hole is one such whisper, a cosmic cry from something just beginning its life, in a universe that has existed for nearly 14 billion years. Let that sink in. Among all the ancient structures, ancient stars, ancient dust, something new is forming. In a galaxy shaped like infinity, two massive galaxies collided, tearing each other apart, compressing matter into chaotic spirals. And from that violence, a singularity emerged. Not the end of something, but the beginning. For centuries, black holes were thought to be death sentences, the final stage of a star's long, lonely life. But now, they may also be origins, fundamental forces shaping galaxies, triggering starbirth, anchoring entire systems. We used to believe the early universe was a slow builder, that everything took eons. But this discovery challenges that. It shows us that creation can be sudden, violent, and stunningly fast. It forces us to re-examine how galaxies form, how matter evolves, and perhaps even how life, somewhere out there, gets its start. And it reminds us of something humbling. We are not the audience of a finished play. We're watching it unfold in real time. The cosmos is not static. It breathes, it changes, it creates, even now. So as we send telescopes further, as we listen more deeply to the signals of space, one thing becomes clear. The universe is still writing, and each discovery is a new sentence, a line in a story we barely understand. Maybe this black hole, this baby hidden in the arms of the infinity galaxy, is not just a mystery. Maybe it's a message that says, don't stop looking, don't stop asking, because I still have so much more to show you.